My name is Engineer Vikas Mashukla. Today we are going to discuss about trigonometry. What exactly do we mean by trigonometry? Trigonometry has its origin in Greek words trigon and metron. As you can see here, trigon means three sides and metron means to measure. So trigonometry means measurement of three sides. It also has its origin in Hindi word called Trigonometry, means the measurement of three angles. So from there we have the origin of this word trigonometry. Now, what do we mean by trigonometry? Trigonometry is the study of the angles and the properties of triangle. As we know from our study of similar triangle, as most of you know, I presume that two triangles who have two equal sides and one equal angle, and there are other laws also about that. So that those triangles are similar, means their ratio of their respective sides are equal. Like two equilateral triangles, no matter what their size is, they are similar, but they are also congruent. So this is called the invariance of the invariance of geometry of triangle. It is a mathematical corollary. So from here we can say that a 60-degree triangle and another 60-degree triangle whose two sides are equal or have the same ratio are similar, and two similar. So based on this similarity of triangle, we can define ratios of sides of different triangles, no matter what their size is, depending on whether their angle is same, whether it is 60 degree, 40 degree, 30 degree. So that ratio will be same. So based on that we define different ratio, like suppose sine theta, it is ratio of perpendicular by hypotenuse of any triangle. So any 60-degree triangle has same ratio of perpendicular and hypotenuse, no matter what its size is. Now as I cleared that up, what is the application of trigonometry? So application of trigonometry is in navigation or measurement of heights and distances, where we only know one angle and one side of any triangular shape. For example, it is a lighthouse problem. Here an observer is watching a lighthouse. He knows he can measure the angle between the base and the top of the lighthouse, and he knows the distance between him and the lighthouse. Suppose it is 50 miles. He can very easily measure the height of this lighthouse. As I said, that ratio of triangles who have similar angle is the same. So applying the same that logic, he can find out the height of the lighthouse. And similarly, there are a number of problems that can be solved using this trigonometry. So based on our previous discussion on trigonometry and ratios of triangles, we can define 6 fundamental ratios that pertain to trigonometry. One is sine theta, that is perpendicular by hypotenuse of this particular right triangle, whose one angle is theta and other consequently 90 minus theta, that is called allied angle. And cos theta of this particular triangle would be base by hypotenuse, base divided by hypotenuse of this particular triangle. Similarly, tan theta would be perpendicular by the base of this triangle, and cot theta would be simply the inverse of tan theta, that is base by perpendicular of this triangle. Similarly, we can define the cosec theta as inverse of sin theta, and sec theta is inverse of cos theta. These are 6 fundamental trigonometric ratios that we are going to study in trigonometry. Now let us discuss about trigonometric identities. Just like algebraic identities that we have already learned, trigonometric identities also establish the relationship between two unknowns. Like as we can see here, this particular identity establishes the relation between two sine and cosine theta values of a right triangle. Suppose this is that particular right triangle with angle theta. So sine square theta plus cos square theta of this particular triangle would be 1. How can we say that? Now let's derive this identity to understand it in the depth. Sine square theta, as we know, is sine theta is perpendicular divided by hypotenuse, and cos theta is base divided by hypotenuse. So this particular is perpendicular and this is base and this is hypotenuse. Now from Pythagoras theorem we know that hypotenuse of any right triangle is square of hypotenuse of any right triangle is equal to square of perpendicular plus square of the base of that right triangle. Now if we square sine square theta, it would give us perpendicular squared divided by hypotenuse squared. Similarly, squaring of cos square theta would give us base squared divided by hypotenuse squared. Adding these two would give us sine square theta plus cos square theta would be equals to perpendicular squared plus base squared divided by hypotenuse squared. That would be the value of this particular identity. As we have already discussed that hypotenuse squared is equals to perpendicular squared plus base squared. So from there we can say this is equals to hypotenuse squared, so this will be equals to 1. This is a particular interesting example how this particular trigonometric identity comes into play, and this is very important as suppose we don't know the particular value of some particular trigonometric ratio, so then we can apply some particular trigonometric identity to get its value. So this is very important. So friends, these are some fundamental trigonometric identities. One is, as we already discussed, sine square theta plus cos square theta is 1. Second one is 1 plus tan square theta is equal to sec square theta, and another one is 1 plus cot square theta is cosec square theta. These are some fundamental trigonometric identities that you need to remember in order to manipulate trigonometric equations to get the results. Now friends, let us derive the value of some trigonometric ratios. As there are infinite number of angles and all of those values we cannot derive, but there are some fundamental angles whose value we can derive arithmetically. So here and geometrically. Here we are going to discuss those methods so that you don't need to remember each and every angle and you can derive it on spot by yourself. So now let us discuss one of those techniques. Here let us suppose our equilateral triangle of side 2a. A is some variable that we are going to leave undefined at this point. Now, as we know from the fundamental quality of an equilateral triangle that each angle of an equilateral triangle is 60 degree and each side of an equilateral triangle is equal. So if one side is 2a and all three has the same length of 2a. So here it is 60 degree and this is 60 degree. Now let us draw an angle bisector from here. This angle bisector becomes a perpendicular bisector to from the property of an equilateral triangle. So this becomes 30 degree, this becomes 30 degree and this is perpendicular, and it divides the base of this equilateral triangle into two halves. One is A, another is A. Hypotenuse is equal to 2a. This also becomes a hypotenuse, length 2a. Now from Pythagoras theorem we can find out the length of this perpendicular as, suppose this perpendicular's length would be equal to square root of this hypotenuse squared minus base squared. That would be equal to, this would be 4 and this would be 3. 4a squared minus a squared would be square root of 3a. This would be the length of this particular perpendicular for this particular right triangle, 3 square root of 3a. Now if I ask you to define the sine 60 degree, so you can take this particular right triangle as a reference. So we can take it from here. Sine 60 degree would be perpendicular divided by base. So perpendicular here is square root of 3a and this would be hypotenuse. So perpendicular here is square root of 3a and hypotenuse is 2a. So 3a divided by 2a would be square root of 3 by 2. This is the trigonometric ratio of sine 60 degree. Similarly, we can define cosine of 30 degree too. You just have to invert this triangle. So this would become sine 30 degree would be equal to base divided by hypotenuse. So base divided by hypotenuse in this case would also equal to square root of 3a divided by 2a. That would be square root of that would equal to square root of 3 by 2. So this is how you can derive the value of trigonometric ratio.